Hello everyone and welcome back. I am Mr. Cobalt and today we're going to go over a problem where we are going to be able to use a chemical formula as a conversion factor. This is one of a couple of problems. Now before you freak out and you see the long problem, don't worry. I chose this problem for a particular reason. And basically, to show that in a lot of problems that you're going to run into, especially word problems like this, those problems are going to have information in there that is going to be useless. It's not going to help you with the problem. It's more like trivia and background that you're not going to use. Even though this looks like a monstrosity of a problem, don't worry. It's actually a little bit simpler than that um, as far as information goes. Okay. So what I want to also do is bring your attention to this roadmap here. This is something that I talked about in another video, and if you, I called it the chemistry conversion superhighway. If you didn't watch that video, I will link it in the description. So just to go an overview of it is that this is kind of the main roadmap that you're going to be using in a lot of problems. In some way or another, you're going to be using it. So you want to commit this to memory. And what it's saying is if you have a mass of some substance A, you can convert A. Let's say you're given some mass of A and they want you to get a different mass, some other mass of a different substance called B, whatever B is. So in that sort of problem, this roadmap tells you exactly what you must do. So you must take the grams of mass A, right? And then whatever substance A, use the molar mass, that's what MMA stands for, molar mass of A, to go from mass in grams to moles of A. And then you're going to go from moles of A to moles of B. So you're going to convert to B using a mole ratio of A to B that you get somewhere. Either you're going to get it from the formula, like we're going to be doing in this problem. We're going to use the chemical formula to get a mole ratio. Or if you have a balanced equation, you can get the mole ratio there. We don't have a balanced equation, so we're not going to use that. Once you have moles of B, now you can convert moles of B to grams of B, mass of B in grams, by using the molar mass of B. And so I want you to be very familiar with this. We're going to use this in the problem today. Okay, so what is the problem? So let's read the problem here. So it says hydrogen may be used in the future to replace gasoline as a fuel. Most major automobile companies are developing vehicles that run on hydrogen. These cars have the potential to be less environmentally harmful than our current vehicles because their only emission is water vapor. One way to obtain hydrogen for fuel is the use of emission-free energy source such as wind power to form elemental hydrogen from water. Okay, and then finally you get to the question, right? So basically all of this is just useless to us as far as the problem goes. It's more of like a sales pitch, right? Or some might say propaganda, not propaganda, but more of like it's kind of like pushing something, right? In this case, it's saying, you know, oh, look, green, go green. In the future, we'll be using cars, and this is how we'll do it, and so on and so forth. And that's great, right? But it's not going to help us with the problem, right? It's okay, so we're going to go green. Great. Okay, so how about the problem, though, right? So a lot of this, it'll freak you out at first, but what you're going to do is you read it to pull out the information. And so far, in the very first part, there was just really no information for us to solve a problem, right? So until we get to the last part, which is the question. So the question here is what mass of hydrogen in grams is contained in 1.00 gallons of water. Okay, so the question, remember what I always say, the question tells you where you're going to end and where you're going to begin. So the beginning of the question tells you the ending, right? So what mass of hydrogen in grams? So we want to know the mass, so I'll put my arrow up here. So we want to know mass in grams of hydrogen. So what is the mass of hydrogen in grams that is contained in, and then this is going to be the beginning, right? So if we continue with the question, it tells us the beginning. Contained in 1.00 gallons of water. So that's where we're going to begin. 1.00 gallons of water. That should be gallons. So G-A-L of water. So this is where we are going to begin. This is where we're going to end. And then we have some other information that we need to use. They give us the density of water. So the density of water is 1.00 grams for every milliliter. So that's going to be an equality, right? So if we write that as the equality, it's 1.00 grams of water is equal to 1 milliliter of water. Okay, so we have a relationship there that we can use. And we need a relationship between gallons and liters. So 1 gallon is equal to 3.785 liters. So given these relationships and given where we need to start and end, we can go ahead and start this problem. So I'm going to start over here. It's going to take several different conversions, and we're going to use our roadmap, okay? But we need grams to get on the roadmap, but they gave us gallons. So we're going to start with gallons. So we have 1.00 gallons of water over 1. So we need to convert gallons first. And our goal is to get onto the road. We need to get on the highway. So right now we're on a side road. So to get onto the highway, we need to start with gallons, and we need to use what they gave us. Okay, so we can get from gallons to liters using this relationship. So let's start there. Since we have gallons, we need to get rid of gallons. So we're going to put 1 gallon on the bottom. So 1 gallon of water. And then we're going to put 3.785 liters. 3.785 liters of water on the top. So gallons of water cancel out. Now we have liters. Now what do we do? Okay, so let's look at where we're given. We're given density. So we have grams of water. So 1.00 grams of water is equal to 1 milliliter of water. I have liters. It would be nice to have milliliters, because if I had milliliters, then I can use this relationship. But I can convert to milliliters using my metric units. So let's do that. So let's convert. So I need another conversion. So I have liters here. So what's my relationship between milliliters and liters, right? So I always put the 1 with the prefix, right? So here I have 1, and then here I'm going to put the prefix multiplier. So since my prefix is milli, the multiplier is 10 to the negative 3. Okay, so now I can use this as a conversion factor. So I have liters on top, so I'm going to put 10 to the negative 3 liters on the bottom. So 10 to the negative 3 liters of water. Notice I'm always writing the substance down. And then 1 milliliter of water on top. So now liters of water cancel out. So now I have milliliters of water. Now I can use my relationship, milliliters of water to grams. And that's going to get me on the highway. So that's going to get me on the highway there. So now I'm on the highway, and then I'm going to go along the highway to get where I need to go. Okay, so I'm going to use the density. So I have milliliters, so 1 milliliter. I'm going to put 1 milliliter of water on the bottom, and I'm going to put 1.00 grams on the top. 1.00 grams of water. So now milliliters of water cancels out. Now I have grams. So now I'm on the highway. My goal is to get to grams of hydrogen. So now I'm at grams here, and I want to get to grams here. So now all I do is I follow the steps. I have 3 conversions to do. So first one is I need to go from grams. I need to go from grams of water to moles of water. I'm going to use the molar mass. And the molar mass of water is 18.016 grams for every mole. You can find that by looking it on the periodic table and figuring that out. So we add. So now I have grams on the top, so I'm going to put 18.016 grams of water on the bottom and 1 mole of water on top. So grams of water cancel out. So again, I use the molar mass. The molar mass of water is 18.016 grams is equal to 1 mole, and that's water. So I use the molar mass. So now I use the molar mass of water, and now I have moles of water. Now I need to use the mole ratio between water and hydrogen, and that's where the formula is going to come in. So the formula is H2O. So for every 1 water, I have 2 hydrogens. So that means for every 1 mole of water, I have 2 moles of hydrogen. So the ratio is 1 to 2. So I can use that as a conversion factor. So here I have moles of water on top, so 1 mole of water on the bottom because the ratio is 1 to 2, and 2 moles of hydrogen atoms. Okay, so now I have moles of hydrogen. Okay, so now I can go from moles of B, which is hydrogen, moles of B to mass. And so now I'm going to use the molar mass of hydrogen. And that's my last step. So now I do my last conversion. I have 1 mole of hydrogen atoms, and the molar mass is 1.008 grams for every 1 mole. And that's going to go on top. So 1.008 grams of hydrogen. Moles of hydrogen cancel out. Now I have grams. I have grams of hydrogen. Grams of hydrogen is what they're asking me for. So I am done. So at this point, all I have to do is calculate, multiply across the top, divide by the bottom, and then I'll get my answer. So let's go ahead and calculate this out really quickly. So I'm going to forget the ones. So we have 3.785 times 1 times 1 times 1 times 2 times 1.008. Okay, now I'm going to divide by the bottom, divided by 1 times 10 to the negative 3, divided by 1, 18.016, divided by 1, equals, and I get 423. So 423.54, and that's going to be grams of hydrogen. And that's how you find the grams of hydrogen. And of course, we're going to figure out how many sig figs we have. I hope this was helpful. Join me next time.